The only 11 years old, I'm 11 believe it or not, that knows about quantum physics, literally. So this is the atom. So let's get started before we all, yeah. So here's the electron. The green dots represent the electron. So like, this is electron, this is electron, they're all electrons. The blue circle represents the neutrons. The neutrons, yeah. So these are the neutrons, all there. And these are the protons. The red circles represent the protons. And the big black ones, the circles, represents the quarks. All the quarks right here. And the small one represents the bosons, which I'll explain what they are later. And see if we can say this. S and F represents the strong nuclear force. So let's get started with the electron, which I'll explain later is really different from these two. It's the oddball, literally. So the green circle, the electron, is kind of like a wave. There's a machine that if you propel electrons through a small slit, it creates a pattern. So it indicates a wave, and plus all other technologies also represent waves. So it's kind of like a wave. It also moves. The electrons are they basically destroy the Flash. If you like the Flash, this is gonna be your new superhero fan. The electron. It moves at 2,200,000 meters per second.
Whoa! Wow!
Imagine zipping around the Earth in 18 seconds. That's this guy right here. So, yeah, in real life, you could run around the Earth in 11 years. So, my lifetime, you could run around the Earth. One Earth. This guy can do it in 18 seconds, so he's speeding fast. And the charge is 0. It's negative, so it's like a negative charge. It's not charged negative. You're not going to lose money. Don't worry. So, the blue one, the neutron, it's made of 3 quarks, which hold it together. So it's not like, not a neutron. It's a neutron because it's quarks held together by gluons. So it has 2 up quarks. There are different types of quarks. It's not just a quark. It's different types of quarks. There are 2 up quarks, 2 down quarks and 1 up quark, and then holding it together and making sure it stays, a neutron. And its charge is 0, so you're going to keep all your money. The same, there it is. You're not going to be in charge. You're not. So the gluon, which is holding all this together, so it's like honey. It's not like a single thing. Honey just kind of oozes all over you, oozes into your bed, and oozes right in my mouth. So it kind of holds it together because these neutrons, these quarks communicate with bosons, which say fire like a machine gun to the next one. You fire information telling it what to do. Send your friend a text saying the directions for a new grocery store, and he sends you the same cooperative. You all end up meeting each other and having a good McDonald's lunch at a grocery store. So they send, and you know why? They don't just send and just fly off into space. So this is why the Earth can exist, by the way. So you're on the face of the Earth, thank these guys. Take gluons, which I explained earlier, is like honey. Definitely oozes into my mouth. I love honey. So onto the neutron. It has a positive charge. You're going to have a big income this year. So it has 2 up quarks and a down quark, unlike this one has 2 down quarks and an up quark. So, and it has 1 down quark and 2 up quarks, like I said earlier, and your income's going to be big this year. Get ready. Get ready to buy the new Tesla car that came out or something. So the quarks, it has a positive charge, and instead of 2 down quarks, it has 1 up quark. Instead of 2 down quarks, it has 1 down quark, and everything else is pretty much the same. Gluons holding it all together, stuff like that. And by the way, this is not the scale. So this is like tiny, like subatomic compared to these guys. They're giant. Let's call these guys small elementary particles. Electron, quarks, and bosons. They make up these 2. So I'll just call them elementary particles, and I'll call these small elementary particles. So these all right here inside the proton, they're small elementary particles, and the same here. So this is the real atom, because now we know what the atom's made of. Now let's go on to the real thing. So if you might have probably maybe noticed But these, if you count the protons, 1, 2, 3, 4, 5, you can see that there are the same amount of electrons here. 1, 2, 3, 4, 5. So that's actually important. There's no element which exists in, on the face of the Earth or anywhere where there are, let's say, 4 neutrons or 4 protons and 5 electrons or 3 electrons or 6 trillion. So that's a lot of electrons. So the reason these orbit in what scientists call cloud formation. So the thing is, have you ever turned a fan on?
Yeah.
You've probably and definitely done that. Looking at you, you love air conditioning. You love it. I love air conditioning too because I sweat a lot. We're getting off topic. We're getting off topic. Enough about the sweat. More about this. So the thing is, it's like a fan. It's been, there are 4 blades, but then you realize there are 4 blades, obviously, and there are spaces in between the blades. Once you turn on, you can point to a space. You can pause time somehow, if you're Quicksilver or something, and then you can point to the empty spaces. But then when you unpause time, if you're Quicksilver again, then you'll realize that it's immediately taken up. And there's a new space, and then you point to that one, and it's taken up as well. So, remember how fast it goes? You know how ants to you, this isn't very fast, I'm walking right now, and it's not very speedy at all, unless you're Usain Bolt. So, wait, I hope Usain Bolt's watching me. In that case, hello. So, the thing is, but to an ant, you're going lightning speeds. It'd be like, imagine seeing a giant alien like a kilometer tall, waving his feet around. For them, it's just waving your feet around. But for you, it's like, it goes crazy fast. Well, to an atom, you move like this, and imagine how fast to them you would be going. So fast. Well, these move way fast. Imagine the ants that can run faster than Usain Bolt, just like a kilometer per second, which it moves way faster than that. It's way smaller, on a way smaller scale, but it moves so much faster. So, yeah, this thing's around 18 seconds around the Earth. Imagine how fast it moves across this distance. Imagine how fast it will move across this. And that's why it's basically everywhere at once. You may be wondering, wait, then why are there inner electrons and outer electrons? And it's confusing. Because the inner could be inner, but then immediately it's down here, like way further than the outer electrons. Well, it's because of called the orbital cloud of...
Probability.
I forgot what it's called, but let's just call it the cloud. I'm not going to be uploading this on the real cloud. So, imagine, this could go here, but then immediately, the likelihood says it's going to come back. Most of the time staying there. So it's pretty much inner and these are outer. These go in and out, it's pretty much the same. I'm just kidding. And imagine if all this complexity, all this about the protons, the quarks, and I forgot. The reason you may be wondering, a ball of plastic and a magnet do not attract. Try it. They'll just fall to the floor and maybe into the sun. And maybe your son will pick it up and you need to go to the emergency room. So, then you need these hold together with this, because, you know why? Because if you try to simulate their own, these will get smashed into protons so fast, it's like, imagine like a magnet in another magnet. You hold it and the magnet drops. But if it's small enough, it goes speeding towards it. So if you don't know, if this proton gets smashed with the electron fast enough, it will turn into a neutron. So you'll just be left with a ball of neutrons. And that doesn't happen because of the strong nuclear force. Hold them together and make sure that these orbit fast instead of crashing into it fast. Okay, now, imagine if all this complexity, the quarks, the S and F. The S and F, I don't want to see CIA or something. So I don't want the S and F, the quarks, the small, imagine all this. Imagine doing this. And then also, it's all here. It's all here. It's all here. Imagine creating the whole world in this. Then it all here. Imagine how strong you'd have to be. God made all of this. That's why everyone was singing praises to him, because we basically have to. It's like who wants to sing the creator of the universe? If you don't, then your financial stuff will become like the electron. You'll lose that. That's good. God did all of this. He created the stage. He created Andrew. He created my dad. He created this stadium. He's the reason why you can exist. So you exist. So thank God for that. Or else you don't, then you won't exist. So thank you. And to remind you, I do not have cancer.